Hi, and welcome to my YouTube channel. My name is Sietze and I have a Master in Sensory Science. Congratulations on the purchase of your red wine tasting kit. This will be a follow-along video, so let's get started. In addition to the tasting kit, you're going to need some glassware.
The size and the type of glasses doesn't matter too much, as long as the glasses are identical to each other. I really like the ISO type wine glasses, because the size really suits the sample size you've received. You can even use disposable cups.
2 identical glasses is the minimum required number for this tasting, but even better is to use 11 glasses. Using this many glasses allows you to go back and forth between the samples. It will also allow you to test yourself on your blind tasting skills later on and blend some samples together to recreate common wine styles.
And finally, find some drinking water and a spittoon.
One layout I really like is where you create a row of 5 glasses in the front as well as a row of 5 glasses in the back, and then keep 1 glass on the side which you will use as your reference glass. Now that we have the required items, let's open the box and see what's inside. There's a handout which lists over 20 different flavor compounds important to red wine. This will also tell you the use by date of the kit, which is 4 weeks from the date of dispatch. Next up is your answer key, so you do have the option of trying all of the samples without any prior information. But for the purpose of this video, we're going to reveal the identity of the flavors and then do a blind tasting test at the end. You'll also find a strip of labels within the box. You can use these to label your glasses. And then of course there are the 11 samples. The 11 samples are all based on the same base wine, a neutral tasting red wine. To 10 of the bottles, numbered 1 to 10, there's a single aromatic compound added. The exception is the bottle labeled with ref, which is short for reference. This is the bottle without anything added. All of these samples are safe to smell and to taste, because the added compound is the same as you would find naturally occurring in wine, and also at the same level, so the same quantity as you will find it naturally occurring in wine. The samples are best assessed at room temperature. Let's go ahead and label these glasses. I really like to label the glass at the bottom, which will become more obvious why during the blind recognition exercise at the end of this video. You don't have to label the reference glass. Let's go ahead and pour the wines. We can pour all of the wines immediately. We don't really have to worry about evaporation of the aroma compound. You can comfortably leave these wines in the glasses for 2 hours and the added aroma will still be noticeable. You might notice a little bit of gas inside the wine samples. These have been preserved with an inert gas blend to make the samples last longer. If you have just 2 glasses, I would suggest to put a reference glass into one glass and then sample number 1 into the other glass. And then as you taste along, you can empty the second glass and fill it with samples 2 to 10, so that you can keep comparing to the reference sample. Great, we've poured all the wines. Now let's proceed to the assessment technique. I will demonstrate you an assessment technique, so a technique of smelling and tasting that I find particularly useful. So I'd like you to pick up the reference glass. Typically we hold the glass either at the stem or at the base. This prevents us from warming up the wine with the heat of our fingers, as well as preventing any stains from our fingers onto the glass. Now please try the following, which is swirling the wine. If you're right-handed like me, then counterclockwise swirling is the easiest, whereas if you're left-handed, then clockwise swirling will be easier. If you struggle with this, best to place the glass on a surface like a table and then draw small circles, and you'll notice that the wine will start moving inside the glass. What happens here is that basically you're extending the surface of the wine. So if my hands resemble the surface, basically you're stretching that out like this. And then the wine is able to release more of its aromatic compounds into what is called the headspace, the bit of air above the liquid within the glass. Okay? Now that we've swirled, we're going to smell the wine. But start smelling from a distance and then gradually bring that glass closer to your nose until you start smelling wine. Now I can smell it from here. I can confirm that by moving the glass away from my nose, and then I notice the smell disappears. So this is a way of finding that sweet spot, smelling from a distance, how sensitive you are on that particular moment, on that particular time of the day, to that particular wine. Okay? Next up, we're going to be following the vapor trail. So we're going to sniff the wine and at the same time move that glass away from us. That looks like this. Okay? Next up, take a short 1 second sniff. Take a long 2 second sniff. Finally, we will cover up the glass with our hand, but before we do that, make sure your hand is free of odor. So if it smells of soap or anything, maybe try to rub it off your clothes and then make sure it's free of odor. Then we're going to gently be pressing onto the glass, making a nice tight seal, and then when we swirl, all of the aromatic compounds will be building up into that head space. Okay, so we'll do this for a couple of seconds, or 1 deep breath in and 1 deep breath out. And then as we move the hand away from the glass, we're going to be taking a long 2 second sniff. And you may notice that during each of those smelling steps, the wine smells slightly different. And that has to do with the volatility of aromatic compounds. So when you're smelling that glass from a distance, when you're following the vapor trail, only the most volatile compounds will be picked up. Examples of such compounds are sulfur compounds. And we'll discuss that in a little bit. Whereas on the other hand, if we're covering up the glass with our hand and then swirling, you're optimizing detection of the least volatile compounds, such as esters and phenols. Now this smelling and tasting technique is optional, it's not compulsory. I think it works pretty well, but during the course of your tasting career, you'll develop your own personal preferences. And I'm just giving you an option, and over time you'll find out what works for you and what doesn't work for you. So now let's proceed to tasting, and I'd like you to breathe in first. Then take some wine into your mouth. We're going to move that wine around in our mouth. And we're going to swallow or spit, and then breathe out through our nose. With that final step of breathing out through the nose, we're engaging what is called retronasal perception. It is a connection to your nose from the back of your mouth. So not only do we smell from the front of our nose, but there's also an access point to our nose from the back of our mouth. And we are paying more attention to that by deliberately breathing out through the nose. Let's try that same assessment technique with glass number 1. So we're swirling the glass. We're smelling from a distance. We're following the vapor trail. We're taking a short 1 second sniff. We're taking a longer 2 second sniff. Then we're going to cover up the glass with our hand. Swirl for a couple of seconds. Or 1 deep breath in, 1 deep breath out. Take a long 2 second sniff. Breathe in, take some sample into your mouth. Move the wine around your mouth. Swallow or spit. Breathe out through the nose. You'll notice that this sample is different. This is the aroma of what most people would describe as a green bell pepper. So I'm not telling you have to smell a green bell pepper in this sample. What I'm telling you is to explore what works for you, what descriptor you need to identify this particular compound, to identify this particular glass. Other descriptors include green beans. You know how uncooked, unboiled green beans, you typically chop up the ends of the green bean, and that releases the same smell. Other descriptors are earth, almost like compost. Or maybe raw coffee beans works for you. In the flavor compounds in red wine handout, under the category primary, you'll be able to find green bell pepper. And on the far right, there's an empty column where you're able to make your own notes. This is a so-called primary flavor. And primary flavors are the flavors that either develop in the grape or during fermentation. And uniquely, this is a flavor that is present in the grape itself. And if you would sample grapes from the vineyard, you would be directly able to notice that green bell pepper flavor if it's there. And that's not the case for a lot of other wine flavors that are only noticeable after fermentation. This is a flavor that's uniquely associated to a group of grape varieties from Cabernet Sauvignon and related grapes, such as Carmenere or Cabernet Franc, for example. They all have the tendency to develop that green bell pepper smell. Now, it's particularly associated with grapes grown in a cooler climate. So when temperatures are somewhat lower and when conditions are shadier, then the green bell pepper flavor develops in a greater quantity. Fruit ripeness is another crucial factor in determining the eventual level of this flavor in the finished wine. So essentially a green bell pepper is an unripe version of a red bell pepper. So it makes sense that if grapes are slightly underripe, you're going to get more of this flavor, which will make it all the way into the finished wine. The detection threshold is quite low of this flavor. The detection threshold is the minimum quantity that has to be present in a certain wine to elicit a flavor at all. In this case, it's 4 nanograms. A nanogram is a millionth of a milligram, and a milligram can be compared to a sugar granule. So we're looking at extremely small quantities in this wine that contribute to flavor. Sample number 2. This is the smell of banana. But not just the banana, it's almost like a synthetic, like an artificial banana. This is a flavor compound that was identified more than 100 years ago. So it's one of the first flavor compounds identified in wine, but also in general. And immediately when this flavor was discovered, it was synthesized and used in all sorts of confectionery. So these days we associate it with confectionery, so sweet products. But at the time, this was considered to be a very natural banana flavoring. And to understand that, we have to know that back in the day there was a different banana variety available in the market. And it was known as Gros Michel. And Gros Michel was a particularly large banana variety, hence the name. And it was also known as Big Mike. There was a problem with this variety. It was susceptible to a disease called Panama disease. And Panama disease basically devastated all the banana plantations worldwide, a bit like what phylloxera did to the grapevine. There was a solution to this. They came up with a new variety called Cavendish, and Cavendish is the banana variety that you see in the shops today. It has resistance to the Panama disease, so all of banana plantations worldwide were replaced with this new variety. People noticed, however, that the flavor was different, so this new variety had a different flavor than a Gros Michel. And later, the two varieties were compared in terms of their content of isoamyl acetate, which is the flavor compound that you find in this glass. And then indeed, the Gros Michel variety had a greater quantity of isoamyl acetate. So whenever you're smelling this glass, or whenever you're smelling a Beaujolais Nouveau, which I will get to in a little bit, or whenever you're trying Haribo sweets, what you're really tasting is the banana variety of the past. So what is this doing in our wine? This flavor is particularly associated with a technique called carbonic maceration, which is a way of producing quite intensely colored red wines that, on the other hand, have very little tannin, so they're really easy drinking, fruity wines. And basically this was pioneered in the Beaujolais. So this is a wine region in France that's famous for this wine style called Beaujolais Nouveau, which is often produced with carbonic maceration. And then frequently you're also going to get these aromas of banana. And what you might know is that there is a particular release day, the third Thursday of November, where Beaujolais Nouveau can first be sold, but there's also a final date when this wine can be sold, and that's the final day of August actually, and it has to do partly because of this aroma, which is not very stable in wine. Initially the wine has a lot of this banana character, but it doesn't keep very well in the bottle, so during bottle aging this flavor rapidly diminishes. So other than carbonic maceration, it's associated with the Pinotage grape variety. So this is a grape that tends to have somewhat higher levels of isoamyl acetate. So whenever you're smelling banana, it could also be a sign of the Pinotage grape variety, which was used in the wine. I find this flavor quite a bit easier to pick up when I cover the glass with my hand. It really builds up in intensity. So that's a big chunk of banana flavor you're getting there when you're using that technique. It's also quite noticeable on the palate. Sample number 3. This is the smell of violet. More specifically, Parma violets, but it's also described as the smell of Turkish delight, or cherry flavored bonbons, or maybe you get a perfume association, like very, very perfumed and floral. This is a flavor that's specific to red wines, and that's because these are basically color pigments degrading over time during fermentation, but also potentially during bottle aging. And these color pigments are more specifically carotenoids, and they tend to accumulate more in the skins than in the pulp of the fruit. And skin contact is somewhat uncommon in white wines, but it's standard during red wine making. Therefore, this is a flavor that you're much more likely to come across in red wines, this violet smell. It's also an interesting flavor to illustrate the concept of specific anosmia. So anosmia is a term for being unable to smell, which is relatively rare. Specific anosmia is very normal. It's not being able to smell certain aromatic compounds, whereas being able to smell other aromatic compounds. This happens to all of us. It has to do with our genetic makeup. We're born with about 400 different olfactory receptors, but that's not the same for everyone. Some people may have 399 or 402, so there's some genetic variation. And this is a flavor that particularly has a huge genetic variation associated with it. So up to 50% are not as well able to pick up violet aroma in wine as other people. So this is a way to find out for yourself. Maybe you can even have the sample try to have your neighbor try it, or someone else, and check if they are able to pick it up. Well, if you're lucky enough to pick it up, this is a pretty pleasant smell. So this is varied in wines because carotenoids are the result of sunlight exposure. Basically, carotenoids offer some protection, so it can be viewed as the sun cream for grapes. So more sun exposure can potentially also result in more violet and floral aromas in red wines. Some grapes that are known to have the aroma more than others are, for example, Nebbiolo or Malbec. So you might come across this flavor in those style of wines. It's also related to the ratio of skin to pulp. So if you have relatively small grapes with thicker skins, then you potentially have more of that violet aroma. And it's controlled, for example, by limiting yields where you're going to get smaller grapes with relatively a lot of skins. Sample number 4, eucalyptus, from the flavor compound eucalyptol, named after where it was first discovered. The sample can also remind you of bay leaf, camphor, or even toothpaste. And it's another aroma compound specific to red wines. And its origins are pretty unique. It sheds some new light on the concept of terroir. Basically, it was discovered that grapes grown in the proximity of eucalyptus trees had more of a eucalyptus character in the finished wine. So what happens is eucalyptus trees grown in vineyards and nearby vineyards have leaves that release this compound eucalyptol. So it volatilizes, it is airborne, so it moves into the vineyard and it attaches to several grape components, so stems, but also grape skins. Now then, when these skins are used in winemaking, which is typically the case for red wines, then it dissolves into the wine and then your wine starts smelling of eucalyptol. So factors influencing this flavor are proximity to the trees. So when you're growing grapes very nearby to the eucalyptus trees, then the level will be higher in the finished wine. Wines that are made from machine harvested fruit are a little bit more likely to have this flavor. because even whole leaves that have fallen off eucalyptus trees can fly into the vineyard and get stuck in a canopy. And then when grapes are not selected during machine harvesting, then those leaves can make it in their entirety into the crush and then contribute a pretty strong eucalyptus flavor. Now, the eucalyptus tree is native to Australia, so its a flavor sometimes associated with Australian wines, but also other regions in the world, including Chile, for example, can have a eucalyptus flavor in their wine. Sample number 5 is the smell of black pepper, so black peppercorns. But once again, this is not the only descriptor. The aroma compound is rotundone. Rotundone is not only present in black peppercorns, but also, for example, in patchouli, which is an ingredient frequently used in perfumery, so it may come across as a bit more perfume to you. Maybe woody is a description that works well for you. And then, unfortunately, there's once again a specific anosmia occurrence here of about 30%, so there's about a 30% chance that you won't be able to smell this flavor, I'm afraid. So what is it doing in wine? In red wines, it's particularly linked to a red grape variety called Syrah. And Syrah builds a lot of this flavor, particularly in skins. It's another primary flavor that can be found in the grape itself. So if you would sample some Syrah grapes with a potential black pepper aroma in the vineyard, you would be able to smell and taste that aroma already. More specifically, these are Syrah grapes grown in a somewhat more moderate climate. So for example, think of the northern Rhone regions. That's where this flavor tends to shine, as well as in New World regions where there's at least some moderating influence. So for example, regions like Grampians or Pyrenees in Australia, where altitude moderates the temperatures in the vineyard. Those are the regions where you could potentially find red wines with more of a black pepper aroma from rotundone. It's also associated with grape ripening, whereas the later you harvest the grapes, the more rotundone is going to end up in the wine, because this is a flavor that develops quite late in the grape ripening process. Sunlight exposure also is a factor here. If there's less sunlight, if the conditions are a bit more shady, then rotundone levels will increase. Sample number 6, this is the smell of vanilla, almost like vanilla pots or vanilla ice cream. It's also a flavor that's very noticeable on the palate. Often this is a flavor described as quite sweet, which is interesting because sweet is one of the basic taste sensations and it has nothing to do with aroma. And the way that we can confirm that this is purely an aroma is by eliminating smell while tasting, and that's done by pinching the nose. So what we'll do is we're going to grab the reference glass first. I'm going to pinch my nose and then taste the wine and hold my nose while the wine is in my mouth and only release it after spitting. Let's do the same thing with the vanilla sample, and then you'll notice that when holding the nose, the wine is no different from the reference wine. Only when you release your nose, the vanilla flavor comes back, confirming that it's your nose at work here and there's no taste sensation involved. So what is it doing in wine? This is a secondary flavor, and secondary flavors are those formed after fermentation during so-called winemaking techniques. And with red wine, the most notable winemaking technique is that of oak aging. So vanilla flavor develops when wine is exposed to oak, which is the most common type of wood. It depends what type of barrel you're using. If you're using a very small barrel, then there's relatively a lot of contact between that wood and the wine, releasing more of that vanilla flavor into the wine. Another factor is how much that barrel is charred or toasted from the inside, with a relatively high level of toasting being associated more with that vanilla character. Then of course new wood, which hasn't released much of its aroma yet, will give you more aroma than wood that has already been used a couple of times to age wines or other drinks. Sample number 7 is the aroma of clove from the compound eugenol. Other descriptors include allspice or male perfume. And this is another flavor that's associated with barrel aging, so from oak aging. But compared with vanilla, this is more associated with more of a medium toast. So a cooper, a producer of oak barrels, will choose their level of toast ranging from medium to all the way to high. Sometimes they use medium plus as a level in between as well. But this is a flavor more associated with sort of the medium charring. It's a flavor often found in oak aged styles. Rioja comes to mind, which is a famous style for using some oak aging. This is a so-called phenolic compound. It's a small aroma compound that has a phenolic group in it. So phenols are often what we also associate with tannins and anthocyanins, which are responsible for astringency in wine, so wine structure, as well as for wine color. But wine also contains so-called volatile phenols, so these are very small phenolic compounds, such as eugenol, that contribute to aroma and that are not linked to astringency. Sample number 8 has a coffee flavor, so it's very roasted in general. Some people even get like a barbecue type of association with this particular flavor. We're still in those oak barrels, oak flavors. But this flavor develops a little bit differently from the vanilla and clove. Vanilla and clove are extracted directly from the wood, whereas a coffee aroma is the result of a reaction between wine components and oak components. So more specifically, in oak, a compound called furfural is released, which doesn't have much flavor by itself, but it can react with sulfur compounds present in wine to form this furfural thiol, which is also known as coffee thiol, and it's the compound that produces this aroma. Sulfur compounds frequently don't have a good name in the wine world because it's associated with a particular fault known as reduction. Reduction often smells of boiled eggs, drains, unpleasant flavors, but this shows that sulfur compounds can actually have pretty pleasant flavors, as shown with this coffee flavor. So the reaction that forms the coffee flavor happens mostly during barrel aging, but also has the potential to further develop during bottle aging. So this is a flavor that will potentially also increase a little bit during bottle aging. Furfural, so that's the barrel component, is produced especially during a higher toast, so a higher charring level in the barrel will give you eventually more of a coffee flavor. On to the more questionable flavors. So number 9, that's the smell of a horse blanket from compound 4-ethylphenol or 4-EP produced by Brettanomyces. If you've never been in a horse stable before, then likely you're not going to smell a horse blanket here. So of course we have some other descriptions for you here as well. Maybe you can think of blue cheese. Some other people find this more medicinal or think it smells of a barnyard. But other people will describe this as being more plastic-like. So maybe one of those things will help you identifying that smell of Brettanomyces. Brettanomyces is a so-called wild yeast. It is a type of yeast that's usually not intentionally making a flavor contribution to wine. The other type of yeast that's famous in wine is Saccharomyces or Saccharomyces cerevisiae, which carries out the normal alcoholic fermentation. And there are some important differences between Saccharomyces and Brettanomyces. So Saccharomyces works very fast. On the other hand, Brettanomyces works very slow. So it's almost like if you could compare it with runners, then Saccharomyces is going to be your sprinter and Brettanomyces is going to be your marathon runner. So it's not nearly as fast, Brett. Brett is short for Brettanomyces, but it can sustain much longer. So it can sustain for a very long time on very little nutrients. It is a flavor that's a bit more associated with red wines compared with white wines. And there are three important reasons for that. So first, Brettanomyces works with nutrients found in the skins of grapes. Okay, so 4-EP is produced from an amino acid that's found in the skins of grapes. Then Brettanomyces is not very happy when SO2 levels, so sulfur dioxide levels, are high. So it can't tolerate it very well. And when acidity is much higher, such as in white wines, then SO2 is going to be more effective against preventing Brett. And then Brettanomyces also likes to hide in oak barrels, which are more commonly used in red wine making. Brettanomyces can consume a type of sugar present in wood called cellobiose, so it can digest this sugar and then sustain in wood for a very long time. So wines aged for an extensive period on oak barrels are also a bit more likely to have a Brett infection. And in terms of if this is a fault or not, many people will consider it as a fault, but some people would say that in low levels it can actually contribute to complexity and can contribute to sort of an artisanal quality in wines. And it can indeed be a component of natural wines and then contribute to its authentic nature of those products. The advice of preventing Brettanomyces used to be just work as hygienically as possible in a winery. And while that's generally good advice, it doesn't necessarily prevent a Brett infection. And in fact, this type of yeast is present in virtually all wineries. So it's much better to outcompete Brettanomyces with Saccharomyces. So if your yeast nutrients are kept low, if your residual sugar is kept low, then Brettanomyces has nothing to work with. Similarly, if you pitch yeast rather than let the fermentation happen naturally, then Saccharomyces is going to be way faster and will outcompete Brettanomyces. Lastly, the most famous wine faults of all time. This is cork taint. And it smells very musty. It comes from a compound called TCA, which is short for trichloranazole. So while musty is the main descriptor, some people think of like an old attic or maybe a damp basement. Also, a swimming pool sometimes has this smell. So again, a wide range of options for you to describe this particular flavor. So, a taint is a wine problem that also always comes from an external source. In this case, that's most usually the cork. That is the culprit here. The way this flavor develops. So phenolic compounds present in the bark of cork trees can react with chlorine compounds picked up from the growing environment of the cork tree. This chlorine mainly comes from biocides, so from herbicides or pesticides used to combat all sorts of problems in the cork tree growing environment. So when these chlorine components react with the phenolic components from the cork tree, a compound called trichlorophenol will form, and you might know that from its commercial name TCP. This is a very effective antiseptic, which means it's effective against many different microorganisms, including several types of mold. And these molds may grow around the cork bark, and then they try to get rid of TCP, which is toxic to them, by converting it into TCA. TCA is not toxic. So this is a coping mechanism of molds trying to get rid of harmful compounds in their environment. And then it produces TCA with this musty smell as a byproduct. So while cork growing conditions have improved dramatically, as well as the production of cork stoppers from those barks has also improved dramatically, it still remains a problem, and it's estimated that about 2% of bottles fitted with a cork can develop cork taint. This is one of the reasons why screw caps are frequently used as an alternative to corks to prevent or to decrease the chances of this flavor problem developing. Now, let's get better at identifying these flavors. So, I'm going to randomly pick up some of those glasses, put them in different positions. If you just do this a couple of times, you'll have no idea anymore which glass is where, and then you can test yourself if you can identify the flavors. This is the reason why we labeled the glasses on the bottom in the beginning of the video. That's so you can check your answers later. You can leave your reference glass on the side, so don't move that glass, don't mix it in, just focus on the 10 flavors and put them in a different position. Now, after you've mixed them up and you have no idea where they are, start again and try if you can name all of these flavors. Okay, we're back. I hope you're happy with how many glasses you got correct in a blind tasting exercise. For the final part of this video, I've put the glasses back in the original order, so from 1 to 10, and we're going to blend some of the wines. So please pick up glass number 1, green bell pepper from bell pepper pyrazine, and glass number 4, eucalyptus from eucalyptal, and just empty the one glass into the other. And then you're going to pour back so that each glass has about equal volumes in it. Okay, now put back glass number 4. What you're smelling here are two very green smelling components together. So we've got the green bell pepper and the eucalyptus. This could be a sign of, for example, a carmenere from Chile, from grapes that were grown in proximity to eucalyptus trees. So it has both that primary character from the green bell pepper from the grape itself, as well as some eucalyptus character from nearby trees. This could also be a characterizing smell, for example, from a Coonawarra Cabernet Sauvignon, once again grown in the proximity of eucalyptus trees. Now pick up glass number 5, Rotundo black pepper, and glass number 8, coffee thiol, coffee, and then mix them together as well. And then you're just going to pour something back that each glass has about equal volumes. I'm going to put back glass number 8. If you smell this, these are two characters that you might find in a syrah. So the coffee thiol is an oak aging compound, but it tends to develop a little bit more in varieties that are somewhat more reductive, such as syrah, which builds more of that sulfur, more sulfur components that can potentially react to form the coffee thiol. So this is both the black pepper primary character together with that secondary character of coffee flavor. Pick up 6 and 7, vanilla and cloves, and then mix it together. This is vanillin and eugenol together. And then put down one of the glasses. If you smell this, it's a very much a character of oak aging. So these compounds will always be present at the same time. Could be in different proportions, but if one is there, then likely the other is there as well. So this could represent, for example, a Rioja or other, maybe a Bordeaux red wine which has seen substantial oak aging. Pick up glass number 6 again, that's already a blend. Then also pick up glass number 9. What I want you to do is just pour maybe a third or so into the glass, so not all of it, but just a dollop. And that if you swirl it, you get that oak character from vanilla and clove, as well as a little bit of Brettanomyces influence, because Brett likes to hide in an oak cask. So if you've done right, if you've added it at the right quantity, then maybe you're at that level where some people claim that Brett can bring some complexity from oak aging. I hope you found this informative. Cheers, and I'll see you in the next video.